In this section, we will be rationalizing denominators. Rationalizing the denominator is the process of removing the radical from the denominator. We will see two different types of problems. These two different types will be dependent on the number of terms in the denominator. So keep in mind, what we will need to do will depend on the number of terms of that denominator. We need to move the radical out of the denominator, keeping the expression equivalent to the one that we started with. When the denominator is a monomial, focus on the radical factor in the denominator, along with the root, and ask yourself what you could multiply it by to be left with an integer. What you do to the denominator, as long as you do the same thing to the numerator, your expression will be equivalent to the one that you started with. Again, the denominator is a monomial. We're only concerned with the square root of 7, not the factor of 2. If we multiply the numerator and denominator by the square root of 7, the radical is no longer in the denominator. You will never be able to completely remove the radical. Just move it from the denominator to the numerator. Before we start multiplying to remove the radical from the denominator, we need to focus on two things. One, we're not dealing with square root, but rather cube root. And the second thing, completely factor that denominator to determine what is the smallest factor you can multiply by to clear the radical from the denominator. After we prime factorize that radical in the denominator, we see the 9b is made up of 2 3's and 1b. A cube root is made up of 3 of the same factors. To obtain a perfect cube in the denominator, we only need 1 more 3 and 2 more b's. Look closely at the factor we will be multiplying by. And again, multiply the numerator and denominator by this. This is the smallest factor we can get away with to clear the radical from the denominator. If we don't go with the smallest factor, you end up needing to reduce your final rational expression, which makes more work for yourself. There's no simplifying necessary here in the numerator, and we do have the final rational expression in lowest terms, since again, we use the smallest factor possible to rationalize the denominator. We're now moving on to a case where the denominator is a binomial. It always takes another binomial to clear the radical in that denominator, and it specifically takes the conjugate to clear that radical in the denominator. This is regardless of whether one or both of the terms of that denominator contain radicals. As we talked about in the last section, the conjugate of a binomial is a binomial of the same two terms, but with an opposite sign in the middle. When a binomial gets multiplied by its conjugate, the result is always an integer. Now, if you recall, a binomial multiplied by its conjugate is always a squared minus b squared. And you can use this as your shortcut if you want to, or you can FOIL as usual. There's a bit of work required to multiply this out. In the end, look how each term has a common factor of 3 and how we have a negative in that denominator. So we're going to have to clear the negative and reduce. What's done on this slide is the reducing required to completely simplify. All the terms are being multiplied by -1 to clear that negative in the denominator, as well as dividing by 3 to clear that common factor of 3. Here's our final result. Notice how the denominator is 1. We were able to remove that radical from the denominator again by multiplying by its conjugate. Thank you for listening.